Thank you. I didn't understand anything of that, but I hope it's good. So, how many of you? It's amazing to see so many people here this morning. I was sure everyone would be like hangover or. How many went to the party yesterday? A couple, yeah. How long did it last? No. So midnight. Okay, that's not too bad. Okay, so my name is Trond. I'm going to talk to you today about Scala and functional programming, approachable functional programming. By that I mean it's not going to be very complex. It's going to be quite easy, and a lot of the things that you see that I'm going to go through here in the Scala tutorial, it's also available for you in Java, luckily after so many years with Lambdas. So who has heard about Scala before? Okay, this is good. Before today? Okay. Who has been doing a small tutorial in Scala? Yeah, a couple of guys. Who has like a small project that they've written in Scala? Hello world kind of thing. Yeah, a couple. Anyone doing any Scala programming at work, for instance? Okay, one guy, that's good, that's good. How about other functional languages? Haskell, anyone? Yes? Okay, this is going to be boring for you, sorry. Okay. Closure, Lisp, like Emacs? No, okay. Okay, so the thing that I'm going to do is to show you some code, and first of all, I'm going to tell you what I'm going to tell you. So, oh, right. Okay, somebody told me that you should first tell people what you're going to tell them, then you're going to tell it to them, and afterwards you're going to tell them what you told them. Okay? So this is what I'm going to tell you. Scala is a great language for learning functional programming. You can start out writing close to imperative code, but if you're a curious developer, you will be dragged into the functional parts and the functional aspects after a while. Or some people get dragged in very early, and some people come there just for the functional parts. And one day, after starting out gently with functional programming in Scala, you might find yourself as one of the guys saying that Scala is nothing for me, it's just not pure enough. Okay, I need something more. So why would you be interested in Scala? Okay, first of all, it's this kind of blend or a fusion between object-oriented and functional programming. So as I said, you can start out pretty much programming like you do in Java, and then you can take other aspects as you go. Second, you have you have a strong static type system. Okay, it's better than the Java one. So your programs will have less bugs. Okay, you can also test a little bit less. Okay, this is nice, I think. Yes. Afterwards, well, I like to think about Scala as this kind of strict parent, the Scala compiler. Okay, so it won't really allow you to do things until you do them well. It can be a little bit hard in the beginning, but well, when you get it right, it compiles, and then you know that most of the time, quite right. Scala also has a great collection library. It has support for pattern matching, which is quite awesome. We're going to see that a little bit later. And it's expression-oriented. Okay, this means that pretty much every construct in Scala is an expression, so it will return some kind of value. Okay, if is an expression, for is an expression, etc. And maybe most important, it runs on the JVM. This means that you can use your existing libraries, you can use the tools, the build setup. It's easier to convince management in your project that Scala is possible to use. Okay, easier. I'm not saying easy, but well, you get it. Okay. So why functional, or what is functional programming first? So it's a discipline of programming where you use where the programs are constructed using only pure function. Okay. So why would you want to do that? Because first of all, it increases modularity. Also, pure functions, they're easy to test, they're easy to reuse, they're easy to parallelize and generalize, and maybe most importantly, they are easy to reason about. Yesterday there was a talk, sorry. Let's get into what a pure function is. Okay, so this is quite a mathematical definition. It's a computation that relates every value of a type A to exactly one value B of type B, so that B is determined only by the value of A. Okay. In another sense, we can say that this function, it should have no observable side effects on the execution of the program, other than to compute the result of the function and its given input. Okay, this takes us to referential transparency and the substitution principle. Okay, so I have a small example here of substitution principle. So we say that if you can substitute, oh, there's one line here that doesn't show up. Okay, so we say that if an expression can be substituted by its value everywhere in the program, it's referentially transparent. Okay, so I created two very simple examples here. So here, for instance, we have this function x that is just addition of 5 and 3. And in the result, we have x times 5 plus 2 plus x. Okay, it could be anything. And the result of this expression is, the thing is that we can replace this x here by the expression. Okay, let's see if we can get the Scala compiler to run. I forgot to start this earlier. Okay. It can be a little bit slow though, so that's the most annoying part of Scala, I guess. Okay, so let's try this. Okay, so we define this function here. Oh, killed. Yes, this is kind of the exciting part of this. So you need to make, like, somebody tell me that you need to make presentations a little bit exciting for the audience. And you're going to see me fail over and over again with my Emacs and my setup here. Okay. Okay, it seems like we are there again. So no, it's not possible. I'm going to kill this one. And let's try again. Or maybe you could just take my word for it. So if we replace x here by its value, we will get the same result. Okay, I'll try once more. Okay, let's see. No. Yeah. I don't know what's going on. This is annoying, of course. Okay, let's get going. So the second part is somewhere where it's not referential transparent. So this is the append method for the string buffer. Okay, so if you call this append new string buffer and we call append to it twice, this will change the state, the internal state of the string buffer, and therefore the append method is not referential transparent. Okay, so as I said, functional programming, you should try to avoid do side effects, okay? So side effects is reassignments of variables. So in Scala, you will typically try to use the val keyword all the time. Then you should try not to modify data structure in place, okay? Scala has very good support for immutable data structure. So the Scala standard library comes with a great many immutable data structures, and all of these ones are chosen by default if you choose, if you want to use. For instance, a map, you will get an immutable map. A list is also obviously immutable by default. You should avoid setting a field on an object. This is also a side effect. So you should try to create immutable objects and immutable classes. We can do this easily in Scala using case classes that we'll see a little bit later. You should avoid throwing an exception or halting with an error. This is bad. And you should also avoid printing to the console or reading user input, file I/O, and screen drawing. Okay, so you might say we cannot create real programs without doing this. So the idea here is basically to separate these things and to put them on the outside of the program, okay, and to have a pure functional core of the program. Okay. So that's the basics. Okay, so we'll get to functions. Okay, and this is also called Lambdas in Java. Okay, so this was kind of the great thing about Scala like 1 year ago or something, but now it's not so great anymore. How many people are using Lambdas? Okay, why aren't you using Lambdas for the rest of you? All JVM, or yeah, you're stuck on Java 7, right? Yes. Okay, so I've written, or I haven't written, I've been copying this quick sort. I wouldn't be able to write this myself, of course, but it's supposed to work. Okay, so this is an iterative quick sort, and it's all like iterative programs. It's a little bit difficult to grasp and get the idea what this is actually doing. So the first part here is the swap method. It's quite easy. So it's just swapping two elements in an array. I have passed the array here, but it's mostly for testing. So yeah, it wasn't really needed. It's just running on the same one. And then you have an inner function sort one that is sorting a subpart of this array. So given by a left index, L, and a right index. Okay, so then we choose a pivot point, and this pivot point is usually the middle point here. So let's see, I think I had a quick no. Haha, there you go. So if you had some collections here with some, oh, I need to jump a line for you. Oh no, what am I doing? Okay, wait. Okay, oh yeah, it's true. Yeah. There we go. And, haha. So now you can see. Okay, so we have the left side and the right side of the part of the array that we want to use, and we choose the pivot point in the middle, okay? And then we move the I and index and the j index towards each other, and we start swapping elements as we go along. Okay. I spent a very long time doing this this thing, so but wait. So okay. Okay. And then we continue doing this. So here we see that we also have a comparator that we can use to decide what kind of or how we're going to sort these elements. Okay, so this should be a quite known pattern. And the idea here is that we could replace this also by a regular function. Okay. So if you want to sort this one, let's try it. So I have some data object here with some different collections. Okay, so times here with a lot of different time, it's hours and minutes, and a sequence is just int. So let's take the numbers first. Okay, so numbers, and we want to sort them. So sort numbers, and we have to provide this comparator. So comparator, new comparator of, so how do you want to write it? Def. And basically what we see is that, yeah, I've been cheating actually. So I have implemented this as a function. Okay, so this is just a type alias for specifying a comparator, and it's basically just a function. And Scala functions, they come in, they look basically like this. So trait, we can take the comparator, how you would write it normally, comparator of t here. Let's forget a t for the moment, and let's just say it's for ints. Compare x of type int and y of type int. Okay, equals x minus y. Okay, and this should now provide us a nice comparator. Okay, and we see here that if you want to use this also for times, we have to use the type parameter. Okay, it's true that it's difficult to type when you're here. Okay, so now we're able to use this, and this one has to be following. Okay, and if you generalize this a little bit more, as we've seen, we get to the function type. Okay, so which looks pretty much like this: function 2 of the first argument, the second argument, and the result type. Okay, so by setting this as an int, this is an int, and this is an int. Okay, we got it. And now the method that we have to implement for the function is the apply method. So why isn't it happy? Anyone? Let's define as type int. Oh, that's great. Oh yeah, the t, yeah. Okay. I'm struggling today. So it's just because I was up all night trying to struggle with Emacs, right? Now, as we've seen, we can write these functions in an easy way. So we can either say new function of int, let's say function 2, int, and def apply x int y int equals x minus y. Okay, but this is a little bit long to do. Okay, so you're also allowed to use the simpler version of it. And that would be this. Okay, so you can use the arrow syntax the following way. And then you can also use, so you say this is that, and you just say underscore minus underscore. Okay. And the compiler is still not happy. Huh. Oh yeah. Oh, there is he. It's good to have a good public. Okay. So let's get to something. Let's get to the next part. So basically, what I want to say is that you can write functions very easily in Scala and Lambdas. Okay. So let's try to sum some numbers and some minutes. Okay. So import T data dot underscore here. And so the idea here is to traverse this collection of numbers that we can see back on the data slide. Okay, I'm just going to. And to traverse it, we can use a method that's called for each. Okay, and we could create a var here, which we could call sum, and we initialize it to 0. And we say sum equals plus underscore, and then we would get the sum out here afterwards. Okay, let's specify this clearly. But this is kind of the bad way to do it. So you don't really want to do this. So instead of looking at for each or a regular for loop, you want to look at the fold methods. Okay, and I think I had a slide on fold as well. Yeah. So the idea here is when you're folding over a collection, you will take an element as a first input, and then you're going to apply this element. You're going to keep track of it, and you're going to start first by 0, as we see here in the parentheses, and then you're going to apply it to all of the elements by using the function that we specify secondly, so plus. This means that here we're going to see 2, 7, etc. Okay, so let's see if I get this working again. I just want to try. I feel. Okay, I'm giving up. Okay. So this is basically the ID. I'm sorry about this technical problems here. Yeah, the other thing we might want to do is to use reduce. Okay, so we see here that fold is allowing us to use numbers directly. So we see that we take this element and then we use it here in the next part. But actually we don't really need that. We could start directly without this without the 0, and we could use the reduce method, which is basically the same without the input that we have. Reduce. Okay. But if you take the times, for instance, and we wanted to count the number of total minutes here, is as minutes method plus underscore as minutes. This will work with a full left because as minutes on this one, and this will work here because we start with a 0 and we get the as minutes from the time. So the first element here is always an int, and the second element is the times that we have in the times sequence. So using reduce in this place would obviously not work because then we couldn't. So full left is more general, and you want to start using full left instead. Okay. You also have map and flat map. Okay. So map allows you to traverse a collection and apply a function to each of the elements and get all the elements back as a result. Okay. So here, for instance, what I might want to do is to take all these words and, I don't know, to uppercase them. Okay. So this will return us a list of all of the elements uppercased. Then secondly, you could also say, for instance, for the numbers, you could do some kind of operation on them. So for instance, we can say that I want to count to each of these. Okay, so the ID here is saying 1, 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3. Okay, so we want to count to each of them. So we can do L map, and here we can say 1, so X here, which is the element, 1, 2, X. So let's try to see what this gives us. Okay. Okay. So here we see that we got all these elements that we want. If you want, we can turn it into a different kind of sequence as well. But in this case, we see that we got a collection of collections back. Okay. And sometimes this is what we want, and sometimes it's not what we want. So we might want to flatten this collection. Okay. And we can flatten it either using the flatten method. So let me write this here instead. Okay, so here we see that we take each of these collections and flatten them. And often we want to do these things directly, okay? So this will actually traverse this collection twice, so it's not optimal. So instead we can use the flat map method that allows us to do this, both of these two things in one turn. Okay, so earlier we also tried to do the two uppercase words to uppercase. So what do you think would happen if we provided, if we sent to uppercase to flat map instead of map? Flat map. Okay, so here you see that they will be all stored like this. Okay. Let's try to turn the quick sort into a more functional version. So we can get rid of this part here. Okay, I'm going to use, instead of arrays, I'm going to use sequences. Okay, this will make things a little bit less performant in terms of memory. And the pivot point is xs.length. We get rid of all of these parameters. So this we're just going to sort for each call to this sort one, we are going to sort the collection that is sent to it. Okay, and we're going to return a new collection, a new sub-collection of this. Okay, we are also going to get rid of all these while loops. Oh, we're going to keep this one. And we're going to use the filter method that we have available on all collections. Okay, so we're going to say xs.filter, and we're going to filter using this comp method here. Xs and pivot. Let's get rid of this. Less than 1. Okay, so this is all the elements that is less than the pivot. Okay, now we have to get the ones that are equal. And obviously we don't have an index anymore, so this will be not the x's. Copy pasting is a bad idea. I'll tell you that. Okay, and we need the last one, which is the last part, and these are the ones that are bigger. Okay, so for these we are good, but we need to sort the rest of them again. Okay, so first we're going to split them. We're going to get the collections back that are bigger than the pivot, and then a second one that is equal, and then a third one that is smaller. Okay, so we can sort this one. We're going to add the ones that are here, and we're going to sort this one like this. And we need to add this one as well. So let me see if I got parentheses right. It looks good. Okay. And the Scala compiler is complaining because when you're doing recursive calls, you have to supply the return type. Okay, and this is going to be a sequence of t. Okay, and here it's not happy because, oh yeah, oof. Equal equals. Okay, and here we can simplify this one as well, and only passing it the x's. Okay, so we see here that we get down to a very much a smaller and much more understandable version of this quicksort algorithm. Even though we have a couple of problems here, so challenges. First of all, we are filtering through the x's collection 3 times. Okay, so what I propose is that we try to improve that. But first of all, I just want to talk a little bit about algebraic data types. Okay, and these are types that allows us to express that something is either something, so one in an ensemble of elements. Okay, so instead of returning an int for the comparison, I want to create a type that allows me to return less than, greater than, or equal. Okay, so the way you can do this is to create a trait, and ideally a sealed trait. This means that only we can modify it inside of the package. Let's call it comparison result. Okay. So this one does not have any methods. Okay. And we can create instances. Okay. So case object less than. Well, let me see. Greater than and equal extends comparison result like this. Okay, and what you can also do if you want to kind of hide this away a little bit is that you can wrap it in a companion object like this. Okay, up, sorry. Where were we? There we go. So the thing we're going to do here is to return a comparison result instead. Okay, and we want to modify this. So we want to extract all of these elements at the same time. So I want to write a small function that allows me to do that. Extract less than, greater than, equal. Okay, let's put them in the order that we want to. And we pass it the x's equals. So x's, and we want to use fold left again. Okay, and as an initial value, we want to pass it empty elements of this type. We need a type parameter here. How am I on time? Do I still have some minutes? 5 minutes, okay. So sequence of t, an empty here. So this is tuple, so it's convenient if you just need some throwaway type at any time. So here we got a tuple as the initial value and all empty elements. Okay, we can do some pattern matching. Secondly, okay, so here we'll pattern match on 2 things. So first of all, since we are folding left, we're going to get one instance of this part here that we are sending in. So a tuple of 3 sequences. Okay, so double parenthesis. So the first one is less than, equal, and greater than. Okay, the second thing we're going to get in is the actual element, the current element. Okay, and we use the arrow here to specify what we're going to return. So in case, I'm forgetting one thing. And here we need to pass. Well, we have the comparison. No, we don't. Some comp. It's comparator of t, and we need to get this out. Okay. I got too much parentheses. Yeah, I need two parentheses because this is a tuple actually. So a tuple is a way to combine multiple elements. Oh yeah, right. Thank you. Yes. Okay, so comp E and the yes. E and the what are we comparing to? We also need to pass it to pivot. I'm getting type T here, right? Let's call it P instead. Okay. Comp ET. And we want to return, in this case, I'm going to do if is bigger than 0. Oh, wait. So, sorry. We're going to do a second pattern match on this one. And we're going to see case. So, less than first. So, if it's a less than, we're just going to return a new tuple with less than plus the element that we're talking about, and equal and greater than. And you see how it will continue. Okay. Okay. So this should give you the extracted elements so that we will only iterate over it once. Okay. I think my time is more or less up. 2 more minutes. Okay. So what more did I want to say? Type classes. Sorry, too much technical problems today. Where can you learn more about Scala? Okay, you can come and talk to me. I'll be happy to go through the examples. I'm very sorry about this. There is also the Coursera free online course with the creator of Scala, Martin Odursky. Well, you can find more information at typesafe.com. You can also try to find a Scala job. There are more and more Scala jobs available. So if you like functional programming, this is a good way to practice. Reading, I can recommend Programming in Scala by Odursky, and also Functional Programming in Scala by Shisano and Bjørnason. And yes, so what I said, I'm not going to repeat it. And I guess thank you.
Thanks.